Hey there, this is part 2 of solving absolute value inequalities um, with a little bit more advanced um, inequality problems. So I'm going to do 4 examples and so let's go. So example 5 here, we need to isolate the absolute value inequality. So I'm going to get rid of this plus 6 by subtracting 6 from both sides. That leaves me with just the absolute value inequality. 3x minus 8 is less than, in absolute value, is less than 6. So then what we do is we set up 2 cases. We have case 1 and we have case 2. So case 1, we're going to keep this just like it's written, but without the absolute value bar. So 3x minus 8 is less than 6. Case 2 is going to be 3x minus 8 is greater than negative 6. So remember, you have to flip the direction of the inequality when you do the negative. Okay, so then we solve each of these by adding 8. And I get the 8s disappear because they add to 0. And then I have on the other side, 3x is less than 14. And then I'm going to divide by 3, and I get my x values are less than 14/3. Now I'm going to put this on a number line, so I'm going to write it as a mixed number just because it's easier for me to locate and think about where it is. So 3 goes into 14 4 times with 2 left over, so 4 2/3. So we're going to look at all the values that are less than or equal to 4 2/3. The second case over here, I'm adding 8. I'm doing the same steps, but I'm adding 8 to negative 6. And my inequality is the other direction. Again, negative 8 plus 8 adds to 0, so I have 3x is greater than negative 6 plus 8, which is 2. Divide by 3, and I get x is greater than 2/3. So I need 4 2/3 and 2/3 to show up on my number line. So I am going to I'm going to start at 0 over here, and there's 1, 2, 3, 4, and 5, and I'm graphing x. And because it's in terms of 2/3, you can either just like write down that it's 4 2/3, but since I can do this, I am going to just split it into thirds. Since I'm creating my own number line, if you're not creating your own number line, then you kind of have to just estimate where it is. But when you're creating your own number line, make it convenient for graphing. So for this first part, x is less than 4 2/3. Well, here's 4 and then 1/3 and 2/3. So less than 4 2/3 means it's not included, so it's around parenthesis and it's facing towards the left. And then the second part, case 2, it's all the values of x greater than positive 2/3. So here's 1/3, here's 2/3, so I'm going to put a parenthesis that way, and any number in this region is a solution to the initial absolute value inequality. And then the next example here, I have a negative 4x minus 7. I don't need to do anything to isolate the absolute value because it's already isolated. So I can go right to my 2 cases, case 1, case 2. Why don't you set up the 2 cases and then come back and check to see if you're doing that part right. Case 1, negative 4x minus 7 is less than 6. Case 2, negative 4x minus 7 is greater than negative 6. And so here we go. We're going to add 7 to both sides. And I have the 7s are gone, so I have negative 4x is less than 13. And I'm going to divide by a negative 4 and think about what I'm going to need to do when I divide by a negative. I have to flip the direction of the inequality symbol. So I have x is greater than or equal to negative 13/4. I'll write that in a mixed number in just a bit here. Case 2, again, we're adding 7, but this time we're adding it to negative 6. So I have negative 4x is greater than negative 6 plus 7 is 1. Divide by negative 4. I get x. Flip the direction of the sign. X is less than negative 1/4. So I need negative 13/4 is the same as negative 4 goes into 13 3 times with 1/4 left over. So I need negative 1/4 and negative 3/4 on my number line. So to make it convenient, I'm going to start with, I'll go over here and put 0. This is 0, negative 1, 2, 3, 4. And they both are in terms of fourths, so if I divide my number line into fourths, it just makes it a little easier for me to graph. Again, if you're not doing your own graph, like if it's already made for you, then you're just going to have to estimate where it is. So let's look at where is x greater than negative 3/4. Well, here's negative 3 and 1/4, I mean, sorry. So here's negative 3. Negative 3 and 1/4 is a little bit more negative. So we're talking about right here, and x is greater than that. So I'm going to put my inequality symbol that way, and it's not included, so it's round, not square bracket. And then for this part, x is less than negative 1/4. So here's 0, here's negative 1/4. It's going to be an open parenthesis facing to the left. All right. I recommend that you try to do examples 7 and 8 on your own, and then come back and check your work. I'm going to get rid of this. Oops. So for number 7, we have the absolute value of 6 minus 2/5 x. So I wanted to throw a couple fractions at you. And that's greater than 2. And then example 8, 4x plus 1 divided by 6 is less than or equal to 2/3. All right. So I'm going to do this. You do it. Come back and check your work. Okay, so we have our two cases. 6 minus 2/5 x is greater than 2. 6 minus 2/5 x is less than negative 2. First step, subtract 6 from both sides. And I end up in case 1, negative 2/5 x is greater than negative 4. And case 2, negative 2/5 x is less than negative 8. I wanted to just pause here or make sure that you recall how to get rid of that fraction that's in front of the x. We have a negative 2/5. The quickest way to get rid of the negative 2/5, so we have x on one side by itself, is to multiply by the reciprocal negative 5/2. If I do that to this side, I need to do it to this other side. So because I have a fraction and not a fraction, I'm going to make the negative 4 into a fraction by putting it over 1. And then the numerators and denominators line up. Here, the negative times another negative is positive, and I'm multiplying by a negative number, so we have to remember to switch the direction of the sign, the inequality symbol. But we'd end up with a negative times a negative is positive, and it's 10 over 10, which is just 1x. So anytime you multiply a number by its reciprocal, it makes it turns into 1. So over here on the right side, I have negative 4 times negative 5, so that's positive 20 over 1 times 2, which is 2, which means I have x is less than 10. I'm going to be graphing that in a minute, and then do the same thing with case 2. All right, so I ended up with x is greater than 20. You can see my work here. I multiplied both sides by negative 5/2. I had to switch the direction of the inequality symbol. And this side on the left is just x. And then on the right, we have 40 over 2, which is 20. So x is greater than 20. So I'm going to graph x is less than 10. X is less than 10. So I went by 10s on my number line because I'm graphing 10 and 20. Those are my boundary points that that need to show up on my graph. So if x is less than 10, it's 10 not including 10, and then open to the left. And then if x is greater than 20, that is this direction. All right, so here's my last example. Go ahead and write it down, and then do the two cases. So I have case 1 is going to be 4x plus 1 divided by 6 is less than or equal to 2/3. My second case is going to be the same thing. Oops, I was going to put absolute value. Do not put absolute value when you split the two cases up. That's taking the absolute value bars and taking care of that. You don't need the absolute value bars anymore. I see that it's a common mistake. So 4x plus 1 over 6 is greater than or equal to negative 2/3. So then we're going to go ahead and solve both of these. Okay, the 4x plus 1 divided by 6, I want to get 4x plus 1 by itself first, so I'm going to multiply both sides by 6. So I'm multiplying this whole thing by 6, which means I have to multiply this side by 6, put it over 1 to match the fraction on that side. The 6's, when I multiply by 6 and divide by 6, that makes the 6 turn into a 1, which leaves me with just 4x plus 1 is less than or equal to, and I'm going to simplify this first. 3 goes into itself once and into 6 twice. 2 times 2 is 4 over 1. I don't need to put over 1. Then I'm going to subtract 1 from both sides. I get 4x is less than or equal to 3. Divide by 4, divide by 4, and this is x is less than or equal to 3/4. Over here, same thing. I'm going to multiply by 6. It's going to leave me with 4x plus 1 is greater than or equal to negative 2/3 times 6, which is negative, this becomes negative 4. Subtract 1, and I have 4x is greater than or equal to negative 5. Divide by 4, and notice I'm not flipping the sign because I'm not multiplying or dividing by a negative, even though this result is negative. It's just the number you're multiplying or dividing by. So I have x is greater than or equal to negative 5/4. So both of these, again, this is negative 1 1/4. Oops, negative 1 1/4. So I'm going to make my number line convenient. I need 3/4 and negative 1 1/4. So when I do my number line, they're negative. So if I go like here, if I start with 1, this is 0, negative 1, negative 2, negative 3. I can put a couple more numbers on here. You just need to make sure that at the minimum, your boundary points show up on the graph. So x is less than or equal to 3/4. Oops, I didn't divide my number line into fourths, which I want to do. So I'm going to have 1, 2, 3. 3 little dashes in there divides it into fourths. All right, so then x is less than or equal to positive 3/4. So I have 1/4, 2/4, 3/4. Less than or equal to means I'm going to have a square bracket. And then negative 1 1/4 is here. And that is going to be greater than or equal to negative 1 1/4 or negative 5/4. So it's all these values in between here that are solutions to the original absolute value inequality. And you can try to pick numbers and put it in for x, and you'll see that anything in this region will make it true. Anything outside of the region should make it false. All right, see you Monday night.